Hi, everyone. We're just going to give it a minute and then we can get started. Hello, everyone. Thank you so much for being here. On behalf of the Environmental Finance Center Network, welcome to today's webinar on Understanding Basic Wastewater NPDES Permit Parameters. My name is Owen Volk from the Syracuse University Environmental Finance Center. Before we begin, we are going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it in the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. One of the many ways EFCN can support your community or utility is through our free funding application support. Struggling with an infrastructure funding application? Falling short on project funding? Not sure where to start? EFCN is here to help. Submit a request through the link in the chat to receive tailored support based on your project needs. And on that note, we can get started. I would like to introduce our presenter for today, Dr. Jason Barrett, Associate Extension Professor and Interim Director at the Mississippi Water Resources Research Institute at Mississippi State University. Welcome, Jason, and I will hand it over to you.
All right, thanks so much. All right, so Owen, I'm still seeing your brief. Okay. Let's go here. All right, Owen, can y'all see the initial slide?
Yep, looks good on my end.
Okay, all right, good deal. So hey, I'm Jason Barrett here with Mississippi State University Extension Service. Just a little bit of some background about where we got to this title and this topic. So my role, I have been with Mississippi State University, January will be 19 years. Initial background in ag economics, and then all of the initial work that I was doing as a 100% extension faculty member has been dealing with public utilities and trying to take, I'm gonna say, the work, research, information, however we may classify it, from kind of the university or a knowledge center, potentially EPA or a WWA, some entity that is creating, down to the citizen level, practitioner level. So that's where I'm gonna say we come from. And then on this topic here, We've had several discussions, internally about this topic. About a decade ago, I got a call from our municipal league, and there was a group of concerned mayors, and hopefully none of y'all have ever had any issues with your governing boards of your public utilities debating on the cost of items and expenses and how things go up. And so I was called to this meeting, and in the meeting, again, I'm mainly listening and answering questions that I asked, but two things that I came away with there with. One is trying to give our utility boards, mainly and primarily water and sewer, the understanding of who has the authority, like what does that authority look like as far as their management of the utilities. And again, that's another subject, another topic for another day. And then the other was the basic information related to a wastewater system. I truly hope that no other states have some of the issues that we see, but it was very apparent to me that a lot of these mayors just didn't have the understanding about what is the wastewater system trying to do. So what does that actual NPDES permit dictate? What does it control? What is it trying to achieve? So I left that meeting, and we proceeded to generate a couple of publications. One, again, related to the authority and structure, everything of the public utilities. And then a second was related to this. Now, you could all search for the publication you want to. It's called Understanding Wastewater Permit Parameters. We created it as an extension publication, and its baseline was trying to get our officials in Mississippi, mainly municipal at that time, kind of a general understanding about what is their permit trying to do. So I wanted to kind of lay that groundwork there so y'all understood where we came into this topic. And another thing, hopefully a lot of y'all are repeat visitors and have heard some of our trainings. You've heard my man, I know Greg Pearson and I did some trainings earlier this year, last year, on some topics, and we kind of tag team through them. We started out with a kind of a surface level, kind of skimming the tops, just kind of gauging your kind of knowledge and interest, and then we dug deeper. I would say this is one of those where we're kind of skimming the top. In a perfect world, I would get all the way through this presentation. Don't know that I will. The first part of it, mainly the bulk, we want to touch on those parameters, and I'll try to talk a little bit about each of them, and then maybe dig into a little real life experience that we've had here. And then second, I wanted to kind of roll into looking at the types of inspections you may see, because when we think about public utilities, a lot of y'all may know this, a lot of y'all may not know this, but there is a regulatory body. So you'll have your local governing body, whether that's a municipality, utility district, cooperative board, whatever. And then you're going to have your state primacy agency. Sometimes it's different than water, sometimes it's the same as water. And then of course you have your federal. We look at EPA. So thinking about how they play into what we're ultimately trying to do. Again, I wish we had a whole lot more time to talk, and maybe we'll follow up with some other presentation topics on it to just start getting a wider breadth of understanding. So let me see if I can move. All right. So looking at this, I'm gonna talk briefly about the permits being created themselves. We'll touch on some parameters. Like I said, I'm hopefully trying to get some of the inspections and inspection things. My desire is to really touch the parameters first. So, Owen, did we plug? What are you thinking on poll question? Do you want me to stop and have a poll question?
Yeah, we can run the poll questions. Do you want to run all three? Do you just want to run the first?
Well, give me just a second. Let me touch on this for just a second. All right, so as you see, I've got up here, NPDES permit, the Clean Water Act, CWA Clean Water Act of 1972, created to address water pollution by regulating point sources that discharge pollutants to waters of the United States. So again, I'm not fully aware of the entire knowledge and breadth of the audience that we have today, but in a general sense, backing it up into the U.S., coming up through the 60s, there started to be a movement where we had a lot of interest in protecting the environment. And you can even look at some of those consequences of those movements with federal legislation, such as the Clean Water Act, such as the Safe Drinking Water Act. You look, Earth Day dates back, I believe it's 1970, and you have the creation of EPA was in this same time frame. So you had a lot of movements coming up, to this time, because if you start looking at all of those actions that exist now, or institutions, departments, they all date back in a very similar time range, all right there together. And even if we look on the water side, you had a huge push to create a lot of our public water utilities to get folks off of shallow drinking water wells where we have high levels of contamination. But anyway, into the Clean Water Act. So when we think about point sources, so what you're looking at two pipes that are discharging into a stream. That is a point source. So if we can actually put a point on it so we know where that discharge is coming off of, I'm gonna say kind of the brother to that, within our Water Institute here, we do a lot of ag water use research. So when you have water running off of an ag field, we can't, in some instances you can, but in general, when water is truly running off of an ag field, there is no point source. It's what we call a non-point source of pollution. So the fact that we can address these point sources, so we can actually sample this discharge to look for specific items as far as what is being discharged into the river, lake, or stream, and how may it impact what's currently in there or what's downstream. So within the NPDES and the point source discharge, we want to be able to monitor what is in there and then hopefully correct that prior to the discharge. So this may be where you would get into the influent, effluent. So influent, IN, influent is the water coming into the treatment plant. Effluent, EF, is the water discharge, like you're seeing coming off this pipe here. All right. So parameters that we're going to touch on. So as you heard me say, when we kicked this off, a number of years ago, I worked with our state primacy agency here, the Mississippi Department of Environmental Quality, and we tried to look at what we would think of as just general permits. If somebody's going to make an application to the primacy agency and say, hey, we need to, down to the most basic, and we just want to create a single cell lagoon for domestic wastewater. That's it. What are almost the basic parameters that you would see fall into that? So we look at flow, pH, dissolved oxygen, biochemical oxygen demand, total suspended solids, nitrogen, phosphorus, fecal coliform. So when we look at these, there's another chlorine residual. It's not necessarily a contaminant. It's more like a flow, or pH is something that you're measuring there, or more like a flow, something you measure there. So one thing I will say within, and we don't get into it very detailed here, there's a whole nother discussion when we start talking about classifications of systems. Now, in some states, it's a 1, 2, 3, 4, where 1's your low end, 4 is your high end, and then there's some states where it's inverse. 1 is the 4 million gallons a day plus, and 4 is your low end. It's the single cell lagoon, non-aerated in those respects. Some states it may be ABCD, so they may use that classification. But from everything I've seen, and just in my knowledge of it, every state is going to have some type of classification of its wastewater treatment facilities. And typically what you see is a class 1 or a class A or a lower class may be your single cell lagoons or small lagoon ponds, no aeration. And then you can typically move into a second tier or a class 2 or a B that may be aerated lagoons. It may have some additional treatments added onto it. You may actually get into activated sludge within your class 2s. And then typically when you get to that third layer, you're going to get into some type of mechanical treatments. And then typically, you know, again, a lot of this is kind of typically in general. When you get into those third and fourth layers, your break is going to be in the volume, it's going to be in the flow. And again, we measure flow, and I'll get into that in a second, in million gallons per day, so MGD. And sometimes that threshold is like a 2 million MGD, so you may have treatment. And then once you exceed that 2 MGD, you may go to the highest level of mechanical treatment that there is. And a lot of the oversight with that will depend on the amount of time or number of visits you have to have with a system or with that treatment facility. All right, so I say that to say each of those facilities, depending on the classification, 1, 2, 3, 4, A, B, C, D, is how often does somebody have to actually visit the system? So you'll start to see an increased frequency. So as you excel up from 1, 2, 3, 4, as you see that escalation up, you're going to see somebody's going to have to spend more time at the facility checking on it more frequently than if we just have a class 1 lagoon that you may only have to visit 1 time a week. And then when we start looking at the permit, each of the permits will have some requirements. And again, we don't get into the labs section of it. We're going to look at the parameters, but I'm trying to kind of move this out of the way. But from the labs standpoint, labs will be conducted, and we call them labs. I say we call them labs. It's the checks on the system in which you're going to look at every one of these parameters. And these are just basics, but there may be some additional. So if you've got a class 1 facility, basic lagoon, you may only have to do labs 1 time a year. And at that 1 time, you will have some form of a lab, whether it's local, whether it's regional. They're going to come to your facility, get an effluent sample, and they're going to check for every one of these parameters that are on your permit. Okay. Now, when you scale all the way up to your highest volume, highest flows, it's very likely you may be conducting. I've been in some facilities where we're checking this every single day, but per your permit, it may only be required once a month, once a quarter. There will be a set time frame in which those labs have to be conducted. And again, it's required by that permit. But from your local checks, from your daily, weekly checks, there will be a specified list of parameters that have to be checked per visit or per labs. So very, very much baseline, your lower level class 1s, you may only have to check flow and chlorine residual. As you scale up, you may have to check flow, pH, and chlorine residual. So you're checking the flow. And again, I'm gonna get into that in just a second. So I'm just wanting y'all to track with me that just because we have all these parameters, that doesn't mean that it's consistent with every system from the smallest to the largest, and that each parameter is checked every single time, because it's not. It's going to depend on the system. And again, not to get off in those weeds, but one of the reasons when we talk with system about rates and management, I'm not a huge fan of looking at my neighbor and trying to mimic, because it's very likely your neighbor's system is not exactly like yours. And as I say that, I have yet to see two systems that are exactly alike. A lot of the systems may be designed as far as the treatment, but the system-wide is different. All right, I'm gonna move. I'm on my soapbox there. So when we think about clean receiving streams, we would love to think that all of our receiving streams will stay safe, clean, pristine, without any harm or any effect. Now, in a perfect world, if everybody is doing their job appropriately, when I say everybody, I mean the people and the treatment systems themselves, because they are designed to treat and meet the parameters that we need, so that anything that's discharged into these rivers, lakes, or streams is not negatively impacted. So one thing that I say a lot when we start thinking about wastewater, and I had an audience here not too long ago of all the basically new mayors and board members of municipalities here in the state of Mississippi, is when we think about the importance of our wastewater treatment, what I like to talk to them about is realize this. You know, there's some slight variation, but about 80% or 8 gallons out of 10 gallons that comes to a household for domestic use of water, about 8 gallons of that 10 gallons, or 80%, is moved on as wastewater, and that's what's going to your wastewater treatment plant. So if you're a community and you know that your water system pumps 1 million gallons a day, you know, it's very likely you're going to be receiving close to 800,000 gallons a day towards your wastewater treatment facility. And once it's treated, it will be discharged into some river, lake, or stream in your community. And it always amazes me to see people's eyes get really white as they are realizing, hey, I did not think about the entire reason that this receiving stream always has good flow is that, you know, 800,000 gallons of wastewater is discharged every single day. And these are the same rivers, lakes, and streams that we are swimming in, fishing in, you know, going on the lake in. I mean, like, these are the receiving streams, these are the receiving waters. And I think it's just very mission critical on our part as wastewater system operators and trainers to educate our boards, to educate our citizens that, like, this is the reason we encourage y'all to only flush human waste and toilet paper down the drains, not put prescription drugs, not put, you know, hair wigs or mop heads. Or, I mean, again, we could run long distance, but ultimately, I really like to lean in on the environmental impact about why do we want to make sure our parameters are met within the acceptable ranges, because this is our water. These are our streams. This is everything that we want to keep safe, clean. So, all right. So we're going to touch on flow for just a second. Flow is y'all may hear me say mission critical a lot, but flow is mission critical. Flow can tell you so many things, but in a general sense, it's simply the amount of wastewater that's being discharged from the facility. So on your permit, the permit will have a basically a maximum. You're going to see, you know, this wastewater treatment facility is permitted for, let's just say, 960,000 gallons a day. So that's its max that it says it can actually treat. So when we think about that, so that's basically your design max capacity. So you should not connect any more homes to it than can produce you know, wastewater, domestic wastewater for your facility. Because if you overload it, there's a lot of issues that can happen. You can have washouts. Mainly your treatment's not going to be able to keep up. If it's a lagoon system, you know, it may be designed on a 45-day holding period. So you may have some short circuiting, so you're not getting the full treatment that you need. But From a flow standpoint, let's think about this. For one, what does flow typically tell me? So in the years when I've had lagoon systems, if I know that my lagoon is receiving, let's just say 100,000 gallons a day, all right? Well, if I come to do my weekly check and it's only reading about 40 or 45, and it's not anything off, nothing crazy, you potentially have an issue. You potentially have a grinder station, lift station that has stopped working, and you're getting a bypass somewhere. You've got an issue. So you can use flow for a couple of things. One being that you can realize that, hey, we may have a problem within our collection system. We're not getting all of our wastewater to the system. All right. Another thing, when you start submitting your DMRs, your discharge monitoring reports, you will need your flow to calculate your loading. So when we think about the volume of any one parameter, that I'm gonna say has a magnitude factor based on your flow. So if you have very minimal flow and high numbers, the magnitude is high. And then, you know, vice versa, if you've got a good flow, you are getting your 100,000 gallons a day, and then the quantity is low, that magnitude is going to be low. So that's good. So that flow is one of those things you'll have to use as you are completing that annual DMR. A lot of you are probably familiar. We've seen some changes in that over the years, in the sense where we used to submit them to our primacy agency. The primacy agency put it in the system that went to EPA, and now a lot of us are logging in ourselves and completing those reports ourselves within the computer software systems. All right, so I talked about the importance, determines the capacity of the treatment facility, which we've touched on that. Shows the amount of water being discharged into the rivers, lakes, or streams. Another point I'll say on that, and I know we'll get into it in a second with some of these others, is within your permit, you know, there will be language there that you may not be able to discharge where you're creating some type of discoloration. You may not discharge if you're creating some type of, you know, excessive solids into the stream. So into the receiving stream. So again, flow can be important. And when you're, again, I'm gonna drop back, the couple of things that you will see on your blanket visit, your initial visit, your weekly visit, flow, chlorine residual, sometimes pH is added. So Owen, hey, I think I wanted to do that first polling question before this, but we're at a good spot if you want to drop the first poll question in there.
Okay, sounds good. I'll run it right now. Okay, we'll give it another 15 seconds.
Where is the poll?
So it won't show up for you.
Okay,
I will
that's
have
fine.
to, yeah, I'll have to read you off the responses.
No worries.
Okay, so responses for the poll, 1% said natural pollution damage easement survey. No one said the second answer, national pond damage energy system. 95% said national pollutant discharge elimination system, and 4% said natural pollution discharge easement survey.
All right, thank you, Owen. So it sounds like everybody got the answer correctly. Is that right? I heard you say 95%, I think.
Yes, for the most part.
All right, good deal. Yeah, and again, my desire there was mainly just to make sure everybody had a good understanding of what that actually meant. And so many times you just hear it referred to as the permit. What does your permit say? But that's actually what it is. And the scoping behind the title of what we're trying to do is discharge elimination. So, all right, I'm gonna move on. So let's, all right, so pH. So pH, for one, I would say pH impacts so many things in the water and wastewater world. And it's very important, not only from our treatment and our treatment capabilities, but in the wastewater sense, you add into this idea of the receiving stream and how it may impact. So I'm gonna go forward, then I'm gonna come back to that. So when we think about what can grow, in these different pH ranges from 0 to 14, one factor to understand and realize is that each number on this is a magnitude of 10. So if you go from 9, well, let's just say you go from 5 to 4, that water is 10 times more acidic than 5, and 4 to 3 is 10 times more acidic than 4. So realizing that range and the value that it has to your receiving stream. So we talk about, plants have more restrictive pH range than bacteria. That's one reason you don't want to hit it hard with heavy acidics, so that we don't impact our plant life, as well as dealing with our fish. And I've got another scale moving forward when we start looking at some DO, some dissolved oxygen. You start thinking about the importance of that receiving stream, so that it does maintain life, does maintain our fisheries. But just thinking about the pH and how it affects the potential growth of bacteria or the continued growth of plants and fish. So pH is just a short for the power of hydrogen. It's that hydrogen expression, in a solution. So I've got here acidic and basic. Sometimes you may hear it as acidic and alkaline, but alkaline is basic. So we're trying to see above or below the 7. So again, the 2 points you heard me talk about, one is how it can potentially affect your treatment. A lot of our wastewater systems have some type of chlorine, whether it's a gas injection into a detention chamber, or whether you just have a contact chamber with chlorine tablets. There will be some contact of chlorine with your wastewater, and pH can affect how well that chlorine reacts. So having the pH within a good acceptable range can give you a lot of bang for your buck, a lot of value in how well is your chlorine doing in actually disinfecting your wastewater before it hits that stream. So when we think about assistance, importance of systems with bonding, preventing of killing good bacteria, and the treatment process needs to be neutral or basic. So you just heard me talk about that, because one thing you can see, as your pond may be getting more acidic, you may find that you're using a lot more chlorine to achieve the disinfection needed. So again, this is where it may be hitting your pocketbook, because if you're, and a lot of what we've dealt with over the years here are our smaller lagoon ponds that simply have a contact chamber. So you may have 2 tubes, 4 tubes, in which you can put your actual tablets in there. And you'll see this ramping up to where you may just have 1 tube of tablets and you're achieving the total chlorine residual that you need. But as you get into, some phase, you may have some excessive loading that's making that a little more acidic, and you're finding that you're needing to add more and more chlorine to receive that chlorine residual needed. So pH is important. Again, not only, as you heard me say, for your treatment, how your treatment impacts that discharge, as well as the receiving stream itself. So I'll go to that. So I think it's important that we realize that, we check that. I know for a lot of our, again, the smaller lagoon systems, your pH may only get checked once a year when you pull labs. You know, as you scale up a little bit, you know, it may need to be checked quarterly. And on some permits, I've even seen like pH has to be checked weekly when you check the flow and the chlorine residual. So I think pH is important, something to realize, something to think about, and just be very knowledgeable of as you move forward with treatment. All right, dissolved oxygen. The free oxygen dissolved in water or wastewater. So when we think about, and I guess one of the easier ways to potentially think about this, there is oxygen in water. We all know that because, you know, fish have been living for thousands of years, and between their, you know, gill system, they take in the oxygen. That's what sustains them. But also think about the breaking down of the wastewater. So there is this very natural, God-given process in which wastewater can break down. If you give it enough space, enough water, and enough time through this very natural aerobic process, it can break down. You know, you'll have oxygen, you'll have the good bacteria that'll break down the solids. So we can have treatment. There's a lot of what ifs and ifs in there. So what we tend to see within systems, as you may increase capacity coming into a lagoon system or a mechanical system, you potentially increase the oxygen within the system. You potentially increase the oxygen in the pond, in the water, and that may be done multiple ways. We've seen it from simply adding aerators to the pond, and whether that's just in the middle and you're putting air, injecting air into it, putting in diffused air on the side where you kind of create some movement in the water. So you're kind of getting a couple of points, I guess, that you're helping with the system. So yeah, so when we think about that oxygen in the system, I mean, what are we ultimately trying to do? We're either trying to account for kind of an increase in I guess, maybe loading within the system, or kind of a speeding up of the breakdown process. And, you know, ultimately, as we scale up wastewater treatment systems, we are simply trying to treat more wastewater quicker on a smaller geographic footprint. And you know, we all know this from an engineering perspective. You know, you can build a 1,000 acre lagoon pond conceptually if you wanted to achieve what you may need to achieve as far as the quantity, holding time. You would have to add a lot of aeration, probably some outfall, other items, but conceptually you could. You know, there's some bounds around that, but instead of burning up 1,000 acres, you know, you can shrink that down, and on, you know, 5 acres, 10 acres, you can put very large scale, multiple MGD plants on that footprint. But because we're adding treatment, we're creating these processes where we can fabricate oxygen, add more movement, add more treatment. We can do what I'm saying. We can treat more wastewater quicker on a smaller footprint. But from the importance of oxygen, y'all heard me talk about the scaling of the kind of the oxygen requirements. I think about this also from a pH requirement. So we start looking at what type of fish can support and live within certain milligram per liter of oxygen requirements that we see. And as you know, we've got that range. You're seeing this, 6 to 9 is kind of your mid range. In some wastewater treatments, that range may be 6.5 to 8, or 6.5 to 8.5, somewhere in that ballpark. Again, it's going to depend on the receiving stream, depending on area. There's a couple of factors in there, but typically you're going to kind of be, within that range. All right, moving on so I don't get too far behind. All right, so biochemical oxygen demand, we think about this, or maybe just known as BOD. So you're looking at that's typically gauged over a 5-day period. And I've got here an indirect measure of the organic strength of wastewater based on the amount of oxygen used by the microorganisms over a 5-day period. So we're looking at how much oxygen is being consumed by the organisms to break down the wastewater as it's needed. So this important, it represents quantity of oxygen which is consumed in the course of aerobic process of decomposition. So you heard me talk about that. As we have the good bacteria that is breaking down our wastewater, how much oxygen are they needing? How much oxygen are they consuming as they are breaking down this loading that's coming into our stream? So in one sense, you think about what is being consumed as they're breaking down this loading. If the loading is fairly consistent across, the BOD may stay consistent. Sometimes, I feel like from what I've seen, you may have these seasonal changes. A lot of it is due to temperature, due to the ponds themselves, due to the system. But it's giving you an idea of the loading that's coming into the system. Because typically you can adjust, your aeration to kind of meet the demand, meet the needs, so that you have the good breakdown. You're getting that process in a very consistent and timely manner. But it's one of those reasons why do we look at it and want to keep a good thumb on the pulse, because we want to be able to meet the demand so that we make sure we're getting good treatment, good breakdown prior to the discharge in the stream. So I saw this and I thought it was a good example. So if we think about looking over in our left kind of context box here, these components, you think about the dissolved oxygen. You've heard us talk about basically the oxygen that was within the water to be able to be used. The microorganisms that are in the actual water themselves, and then the organic matter, organic material. So when we think about this healthy water having this balance of these. So when your water has excess organic matter, the microorganisms begin to break them down, and that's by design what we'd like to see, but it's going to be using up the oxygen during the process. So this starts to reduce the oxygen levels. So if this oxygen level is not, maintained or increased to continue the breakdown, that's when we would begin to have issues, have excess loading, and it would greatly affect the discharge, greatly affect the receiving stream. So keeping a good check on our BOD is vital, because we do want to make sure that we have good, consistent treatment, good, consistent breakdown of the organic matter that's coming into our wastewater treatment system, again, whether it's a pond or whether it's an actual treatment facility. All right, TSS. So this, I think about this, a lot of what I've known of this is from what we would call turbidity. Basically kind of the I almost want to call it the inconsistency, of the water. So as you look, is it dirty? But on a permit, you're going to see total suspended solids, TSS. So the solid matter that is suspended in wastewater and will not pass through a filter consists of both organic and inorganic solids. And I pulled a picture because I like visuals. So I'm going to show this and then I'm going to come back. So when we think about our treatment, when we think about our discharge, when we think about high TSS versus low TSS, and also you can look here from NetSol, low turbidity looks like a very clean, pristine water versus high turbidity, which very much almost looks like influent coming into the system itself. But this really gives you a good range. You know, it's an easy spectrum of 5 beakers here of different levels of TSS, basically from 0 up to the maximum that you may see. All right, so you know, solids in the water that can be trapped by a filter can cause problems for stream health and aquatic life. So, you know, ultimately you would like your effluent, your outfall pipe, which you may be sampling, to be clean, to be clear, to look like that low turbidity picture that we had, because the effluent coming in, of course, is everything that you're receiving from your wastewater treatment, from your collection system into the wastewater treatment plant facility. So as you move again through classifications, if we look at lagoon systems, you know, it's very common that a lot of your solids that are not strictly human waste, they almost get passed through. I mean, you end up having them caught in certain things. They form on the surface. And again, to me, this is a very important spot where we really need to educate or try to educate our customers, homeowners, about the importance of not just putting random things down the sink, down the toilet, down the shower, because ultimately we see it. Now, as you scale up with our mechanical treatment plants, a lot of them will have, if not all, will have some type of headworks, grit chambers, where you're trying to get a lot of these things out of the system, out of the effluent, so that your actual treatment plant can treat the wastewater and you're not dealing with rags, mop heads, wigs, toys, tampon wrappers, just multiple things that have no business being in wastewater. So again, you can kind of process those through. And again, that's why we have scaling up of our wastewater treatment system. But scaling it back a little bit, TSS, total suspended solids, it will be a factor. It will be on that permit. And y'all saw me walk through this. When we think about another term, you may want to just kind of put it in your memory. Another term you may hear is turbidity, low turbidity, high turbidity, very synonymous with high TSS, low TSS. All right, we're going to hit on kind of the nitrogens for just a second, some of the components. Again, y'all heard me say here at the Water Institute, we do a lot with agriculture as well. And it's always so important to, it's always so interesting to me that from an ag perspective, what do we do when we're trying to make our crops better? We put out nitrogen, phosphorus, potash. We're putting these components out onto our soils to try to help our plants grow. So that's great. You know, in a perfect world, if it could all be taken up and consumed by the plant, that's not actually what happens. You know, very similar when we get over into wastewater, we will have some of that into the wastewater. So ammonia nitrogen, the amount of ammonia in the wastewater, ammonia creates an oxygen demand in the receiving stream when pH is neutral or acidic. So when we look at this other component, this other item that's demanding some oxygen from the water, so you already have the organic breakdown. Now you've got ammonia that's consuming some of your oxygen. So these are some of the items that we see as far as why it is important to be able to check dissolved oxygen. Why is it important to make sure that we're getting plenty of oxygen in? Why is it important to know the loading that's coming to our system? Because that's going to impact the demand on the oxygen for the breakdown. So importance may create a gradual change of a water body into a marsh, meadow, then a forest. It can lead to algae blooms and oxygen depletion. Too much can be bad. So, we've had these discussions for, years now. I know that the Gulf, where the Mississippi River meets the Gulf, and I guess it's the Gulf of America now, as it meets the Gulf, there's what we call a hypoxia zone down there because of the massive amounts of kind of nutrient loading down there that creates this depletion zone. So the importance, we saw that it's vital in my mind when we think about what's there. Some of the permits, I don't think I mentioned this, depending on the permit, depending on the size of the system, when it comes to ammonia, when it comes to nitrogen, it may be actually, it may have a range, it may actually just state what that is. So just total nitrogen, combination of all the nitrogen compounds that come into the system. Most municipal treatment plants would look at a single form of nitrogen. When we flip to the water side, if we have nitrates, nitrites, we see that as contaminant in our water. So from a wastewater standpoint, we want to be able to determine if we have it in there, and if so, how much. I've got a picture, as I've told y'all, I like visuals. So when you have some excess loadings, as you've heard us talk about, as these the nitrogen, ammonia, nitrogen, total nitrogen, whatever I guess characteristic we want to give it as far as a title, as it hits the receiving stream, it can have very negative impacts. So you see on the left, you see basically a die-off of fish because it depletes the oxygen, which doesn't allow enough for the fish to maintain, and that could be a factor of a couple of things. Of the water's too shallow, not enough flow, stagnant, and then on the right you see this movement into this river. When we think about blooms, when we think about the heat and its impact on the water, algal blooms are becoming something that we're hearing a lot about, not only from just wastewater treatment, but we're starting to even hear about them in water production plants that may have reservoirs as a source. The impact of algal blooms and growth on it. But from a nitrogen standpoint, it can very much negatively affect a receiving stream. That's one of the reasons we want to keep it, in check. All right, so phosphorus, as you heard me talk earlier, the couple of components, the nitrogens, phosphorus. So phosphorus is a nutrient used by organisms to grow. Not all permits have limits. They may just have to monitor a report. You heard me say that just a second ago. But it can very much trigger an algae growth, oxygen depletion. There's another parameter that can be in the water and if not kept in check, oxygen adjusted accordingly, can really impact the treatment. It can impact the receiving stream. And I got another, so you see here, basically you've just had aquatic growth in this stream here. What you have with that is as this plant life, as this algae grows, what you will see is its consumption of oxygen, and then from that you see kind of a reduction for its availability for your fish and other aquatic life that may be in there. So it's good to really keep this in check. Moving over here to fecal coliform. There's a couple of things when we think about, you may have a kind of an umbrella term of, some people are aware of the term total coliform that you may talk about when we have public water supplies or private wells where we're checking that for safety. And then fecal is nested within that, is bacteria found in the intestinal tracts of warm-blooded animals, humans. This indicates a presence of pathogens, and then E. coli is one of the fecal bacteria, and this is something that can very much impact humans, impact their health. It's not good. But one reality is if you have domestic wastewater, you are receiving domestic wastewater that will have human waste in it. So if you receive or have a domestic wastewater system and think that you will not have fecal coliform, you're fooling yourself, because you are directly receiving domestic wastewater that's going to have, again, fecal coliform in it. And again, that's the way it's built and designed to receive that. And as I've noted here, it's the most common microbiological contaminant of the waters. It can cause disease in humans. But one of the parameters on here will be you're going to have to count, and a lot of times this is in the colonies per 100 milliliters, and it may be a graduate down. But you will do this. A lot of it's still done on like a petri dish, where you will count the colonies, and there will be an acceptable range. So when we think about influent coming in, you'll have the natural breakdown, hopefully the natural breakdown within, if you're assisting it with excess oxygen, movement, whatever that may be. Then you will have some type of contact, chlorine contact, which the chlorine coming in contact with the waste, and hopefully you have some type of detention chamber. So chlorine mixed with the water that may have bacteria in it over time, hopefully that will kill as much as humanly possible before it actually hits the receiving stream, because you do not want an excess of fecal getting into the receiving stream. And I do have another photo of that. So you can, and again, you may say, well, these things, a lot look similar, as you saw from the fecal here, the phosphorus and the nitrogen. And I'd say this: if you have a receiving stream that is beginning to look like this, you've got a problem. You need to figure out what's going on with your treatment itself. One of the last parameters, also one of the things that you may look at, and it will need to be looked at every time, is your chlorine residual. Y'all heard me speak earlier. You may be introducing chlorine in a gas method. It may be you may have it in I think it's the sodium hypochlorite liquid method, or you may have it just in contact chamber with tablets. Multiple methods of getting the chlorine in contact with that wastewater, but you will have some form of disinfectant, typically using chlorine. So the amount of chlorine remaining in wastewater after disinfection. So when we check our receiving effluent going out, we want to check for that. And if you're running a hot meter or a Lamont meter, you're gonna run it for total, not free. You're running for totals. You're checking to see, and that typically ranges from 0.1 to 1.0 is what you're trying to determine, because excess chlorine can be an issue. I mean, you really need it within that range, because you want to make sure that you're killing and disinfecting, killing the bacteria, having it disinfected before it hits that receiving stream. But we all know, chlorine in excess amounts can also be harmful to us. So we need to make sure that we check it when we check it before it goes out, and that is our range. So I've got here the importance. Residual shows that all bacteria have been killed and that a trace amount of the chlorine remains. And again, if it is just trace amounts, it'll probably dissipate as soon as it hits receiving stream, because we all know there's going to be some form of bacteria, in that receiving stream. All right, so I'm gonna hit Owen. Did we have one more poll question? Could you do one more before well, let me do this.
Yeah.
One more poll
Okay,
question.
I was gonna say we have two more. We also are running very, very short on time.
Yeah, I'm gonna wrap it up. I had this sphere, so that's why I broke it up like I did. So the importance to our facility, I've got this, legal requirement. As much as I hate to ever come down like that, the reason we follow the permit is required. Federal law through EPA, state law through State Primacy Agency. Essential resource. The rivers, lakes, and streams, they're a vital part of the hydrologic cycle. Again, that's been going on for 1,000 years. to me, we need to do our part in being good stewards of this resource. And then multiple uses, y'all heard me dive into that earlier. These are the rivers, lakes, and streams that we use for drinking water, industrial purposes, recreational purposes. So they are vital to what we do, so we need to do our part and make sure it's safe and clean as we discharge. All right. Thank you, Owen.
Yeah, no problem. We did have a few questions, if we wanted to run through those. One moment. Just so everyone knows, if anyone does have any questions, feel free to share them in the question dialog box. I know we're running up on time. If you do need to leave, that's totally fine. We'll just run through the questions, and then there will be a video sent out in the recap email. Okay, so the one question that we have right now is, what is the potential of using algae as a way to remove nutrients in wastewater?
What is the potential of using algae to remove nutrients in wastewater? Ooh, well, the only thing that comes to my mind is I know there have been some operators that I've worked with over the years that have had ponds that are covered with some form of algae, and instead of trying to get rid of it through one form or fashion, they say that it helps them with their limits, and they are within their parameter ranges, so they see no use in trying to get rid of it. So I personally have never seen it like introduced as a method to help, but I have seen systems where there is some form of algae there and they leave it alone because they say it's fine. So I don't see that as really answering that question, but I have seen where algae has been in place and they see no problem with it.
Okay, awesome. I think that was the only one that we had. I will give it a sec if anyone else has anything. Otherwise, we can get wrapping up. Someone was wondering if you could just briefly jump back over the phosphorus parameter again.
Jump back to it.
Yeah, just quick recap on that.
Let me see where it is. So phosphorates, nutrient used by organisms to grow. Not all permits have the limits. Most are required to monitor and report. Again, when I touched into this, I was talking about you may see ammonia, you may see the nitrogen, phosphorus, which we typically see from one sphere of our I guess our system, which we use it as a very good positive thing because we're applying it to soil to help our crops grow from an ag perspective. But then on the wastewater side, those are seen as contaminants because in the receiving streams, you may see how it kind of heightens the growth of algae, heightens growth from other plants, and just about everything that it's going to, I'm gonna say, have a very positive benefit on plant growth, tree growth, algae growth. Those tend to kind of reduce our oxygen or put a higher oxygen demand on the river, lake, and streams, so it could impact your aquatic life. So, yeah.
Okay, fantastic. Well, I haven't seen any other questions come in, so we can wrap it up there.
Okay.
A huge thank you to Jason for sharing his expertise with us today. Following this webinar, you'll receive a follow-up email with the slides from today and a link to the recording. We also ask that you complete the webinar evaluation following this webinar so that you can let us know your thoughts on today's session, as it helps us plan future webinars on topics that are important to you. Thank you again, and we hope to see you at future EFCN events.
All right. Thank y'all.